Good morning, everybody. I hope you have slept well and long enough, but I even hope more you had a good time yesterday and have a better time even today. Um, we're going to start the track today here with something more philosophical. In the beginning, God created Earth. Well, some of you might believe that. I actually don't. We can have long discussions about that. But there's one thing I think we all agree on, that is that shortly after that time, IBM created the AS400. And whether it's still a dinosaur living way beyond its expected lifetime, or it's a highly evolutionized system that meets up to the challenges of today, Tom will discuss all this with a technical introduction to the AS400.
Test. Okay. So good morning, everyone, and thanks for being here. I will explain a little bit, give you some information about the IBM AS400. So first, a little overview about what I will talk about. So I will first introduce myself, and then get to the interesting stuff. First, a little history about the AS400. Then we will get to IBM I, so I will explain what that is. Then I will tell you something more about some other environments that are available on the system. A bit about programming, how work is done on the system, and well, I will show you some interesting stuff that you can do on the system at last. So, who am I? I was AS400 system programmer for a few years, and yeah, I really liked the system. So I wrote some business logic in RPG and did some system administration, so I'm not really a guru or something. I currently work as a Linux system administrator at PREP Belgium, and I'm a Linux and BSD user. I put my tent up in the Belgian village, so if you want to see me, you can go see me there. So, why did I want to do this talk? Well, in 2008, the AS400 celebrated its 20th anniversary, and well, if I talk to people about the system, they all think it's really old, but actually it's only 20 years old, so even Unix is older than that. And the mainframe is also older than that. So I said, well, let's just do a talk about it. And yeah, I don't know why you are here, but if you're interested in the system, I brought an old system to play with. So if you want access to it, you can see me after this talk, and I give you access to it. It is a system. The system is installed in the Dutch language, so that's good to know. I don't have tapes for other languages, so I can't reinstall it. In no way I represent IBM, so everything I say is my views and opinions only. So, a bit of the AS400 history. It was developed in by IBM Rochester in Minnesota as a mid-range system, so that means it's actually a small mainframe. And it's very different from all the other systems that are around, like Unix. It works in a very different way. And it is extremely closed source. Even within IBM, it is really closed. It was developed as part of Project Silver Lake and designed by Dr. Frank Soltis. That's the man on the picture there. So, Rochester started building systems with the system tree in 1969, and they built some other systems which I have pictures of. So I'll go to the pictures. So this is the first one that came out of Rochester. Yeah, I like pictures, so then it was followed up by the System 32 and the System 34. And then the System 38 was created, and that was actually a whole new system. And the operating system software that ran on it was called Control Program Facility. So this was a whole new system. Then IBM created another system, the System 36, as a follow-up of the System 34, because many of its customers didn't like the System 38 because it was too big and it's expensive for their needs. And they want to satisfy the customer's needs, so they did create the System 36. Then IBM started a project called Fortnox, and they wanted to combine some of their mid-range systems into one new system. And they even went so far by declaring the System 38 as being non-strategic and discouraged people from even buying it. So that was not a good thing for Rochester. And the project failed, so it left Rochester basically with nothing. But they did have a backup plan, and that was this project Silver Lake. So in that project they created the AS400, which was actually in many ways just a new implementation of the System 38. So you can see there were these are actually pictures of the first systems, and yeah, there are small systems and the big ones. So in the past, IBM renamed this system many times. They first added an E to it because it became an E server. Then they renamed it to I series, the I standing for integrated. Then when they released their Power 5 processors, they renamed it to E server i5, and also the operating system was renamed from OS400 to i5 OS. And then, yeah, they renamed it to i5, System i5, and eventually it became the System I. Now, this year, IBM released the Power 6 processor, and the System I kind of like disappeared, because the System I and the System P already used more or less the same hardware, and with the release of Power 6, they combined these systems into one system called the Power Systems. And they also renamed i5 OS again to IBM I. So that's the old and the new logo. So these are the latest systems. So also the old ones and the new ones and blades and everything. And you can run AIX, IBM I, and Linux on them. So what is actually IBM I? So that's actually the operating system of the AS400, but yeah, renamed. And it is built up by some design principles. So I will talk about every one of those. So first one is technology independence. That means that that IBM I is not defined by hardware. It actually talks to a virtual machine interface called the technology independent machine interface. And this technology independence was also demonstrated in 1995 when the system moved from 48-bit CISC to 64-bit RISC system. Customers could just save their programs on the old system and move them, restore them on the new system, and they would just work. They didn't have to recompile it. So this is another view. So you can see the IBM I runs above the machine interface, the virtual machine interface, and below that there is the kernel called the software licensed internal code. So first it was written in PLMP, and they rewrote it because they wanted to do it in an object-oriented fashion. And what's also nice to know is that the system already defines all pointers as 128-bit. So if at one time in the future 128-bit processors would appear, IBM I would already be 128-bit enabled. The next thing is that it uses an object-based design. So the only supported data structure at the MI level is an object. Yeah, and that's nice because yeah, objects are atomic, and you can't just. It has some security advantages. It brings some security advantages because yeah, you can't just treat an object as an executable, and you can't just change parts of the object because yeah, it's atomic. And objects talk to each other by passing messages. So every addressable object has a message queue attached. And yeah, almost everything on the system is an object. Yeah, the only supported data structure. But it is not a fully object-oriented system because it lacks some object-oriented features like these. The next thing is hardware integration. The AS400 was first built to perform in information-intensive environments, and with the move to PowerPC, they wanted to add support for Java and e-commerce, business intelligence things, and they wanted to create a balanced design with this fast processing from the PowerPC, combined with the high bandwidth and high performance I/O that the original AS400 was built on. Also, the power processors capacity is expressed in commercial processing workload. So they disregard the CPU speed and instead base themselves upon transaction processing benchmark. The next thing is software integration. So a lot of software is already integrated in the system. That's not very special. But one thing is really nice, that it comes with a modern database, DB2-400. And these things are all installed by licensed programs, which you can patch with PTFs. And you can install these fixes permanently or temporary. And that's also a nice thing, because this is the power down sys command. You can choose an IPL source. So if you install patches, temporary, they will be on the B side. And if you IPL your system and it seems that something doesn't work, you can just revert your patch by booting on the A side. And you also have a D side for tape and a C side for modern systems that have an optical device, so mine doesn't. And this is another thing, the single level store, that's special about the system. Frank Soltis developed a single level store or researched that in his PhD and implemented it in the System 38. So the AS400 has this. And that means that it has one large storage, a 46-bit address space that contains everything. And the addresses are never reused. And there is no process local storage like in Unix, so that should speed up things like task creation and context switching. And the programmer does not have access to real memory. So the virtual addressing make sure that the object is moved into real memory. So, some other environments that are available on the system is PACE. This is an incorporated 46-bit runtime environment available inside the IBM I. One thing about the system is that it's not technology independent. It does not speak to the machine interface, but has a syscall interface to the kernel instead. And you can use PACE from IBM I and call IBM I from PACE and do all kinds of stuff like run queries and even run X and Apache. The system also comes with a hypervisor, which is supported by the PowerPC architecture. And you can make logical partitions inside the system. So you can make partitions for AIX, Linux, and IBM I, and make them run next to each other. They are all created and managed from the hardware management console, which I will talk about in the next slide. And you can dynamically allocate resources at runtime to these LPARs. So, management of the system is done from the hardware management console. So the early systems had just an old or now obsolete Twinx console, but that was replaced by the hardware management console because these LPARs were added. So the management console is used to IPL a system and use service tools and do the LPAR partitioning. And the HMC is connected to the IBM I on a private network. And yeah, the HMC and the IBM I are connected to the LAN, so they are available to the workstations too. So some bits about programming. There are several languages available on the system. Some of them are really old, some of them are a bit newer. And the original programming model on the system was called OPM, so for RPG programming and COBOL and CL. And later there were some languages added, but when you compiled your program, it was translated into a real program, and this program was morphed into a PowerPC program by the optimizing translator in the SLIC. And the only call that was supported was call external, and that so all references had to be resolved at runtime. So that was maybe a bit slow. So they created a new environment. So they brought a new compiler, optimizing translator, and binder facility to the system. So from then on, when you compiled your program, it turned into a module that was packaged into programs or service programs. So that was a way to do early binding, and it's not really that much different from how other systems do it. There's also support for Java on the system. So when you compile your code, it turns into bytecodes, and these bytecodes are part of the machine interface. And they are used by the Java virtual machine, which is also implemented directly in the kernel. So that's the native JVM. And you can also install the AIX JVM inside PACE if you want. Okay, so how do you do work on the system? So a logical unit of work is called a job, and there are several types of jobs. These are the most important ones. So interactive jobs are called, and batch jobs are submitted. And a job is uniquely defined by a job number, a username, or a job name, as you can see in the print screen. So the job name is called QPA dev 002 by the user QSecoffer with that number there. And these numbers are never reused. So this is an example of the message queue for my user profile. I submitted some jobs, and you can see that the job number just increases. Now, jobs run inside subsystems. There is one big controlling subsystem on the system, and the system comes by default with these two controlling subsystems. You can set them in a system value, and the QCTL subsystem will create all these subsystems, and the QBase subsystem will only create a part of those, a subset. The subsystems then are actually started by a program that's defined in the starter program system value. And if you want to put your system in a restricted state, that is also possible. So you can just end all subsystems, and you can run your backup jobs inside the controlling subsystem. So you bring everything down, all logs are off your files, and you can just take your backup. Many people actually do that. This is an example of the startup program. So this is the line of code that starts the QInter subsystem. And this is the work active job command. So this is actually a job that's running. It uses 22.07% of the CPU. It's an interactive job running on my workstation. And yeah, the user is QSecOffer. And it runs under the QInter subsystem. These are some other types of jobs. For example, AutoStart job, batch job, a subsystem, a writer job. And there are also the system type jobs. For example, the database server. So the database server jobs are type system. Jobs do not directly run into the subsystem, but are placed on job queues. So batch jobs are placed on job queues, and interactive jobs are placed on the workstation queue. And the subsystem take jobs of multiple queues, and the jobs just have a priority on the queue and are processed in a FIFO way. But this is an example of the batch, the queue batch queue. Job queue, and yeah, you can also see the name of the job, and the user and the job number, and it has a priority. And I put it on hold because otherwise I couldn't take the print screen. Okay, another nice thing is that you can divide the memory of the system into storage pools. By default, there are two major pools, the machine pool where all the system jobs run, and the base pool where everything else runs. And you can create your own pools for other things if you like. And the nice thing about pools is that they are dynamic. They can adjust their own paging options and their own size and job activity level if you set the right system value. And you can also create fixed size pools to run some jobs in. That's also supported. These are 4 pools that are on my system. So the 2 default pools, and I created 2 extra pools for interactive jobs and for spool jobs. Then you can assign these pools to the subsystem by assigning it to a subsystem pool. So by default, every subsystem uses the base pool. And if you want to put jobs in other pools, you can add these. So I created a pool for the QInter subsystem and for the spool subsystem. And I can assign them there. So, for example, the QInter subsystem, this is another view. So the first subsystem pool was assigned to the base pool, and the second was assigned to the interactive pool. You can also see how much of the capacity of the pool is used, and yeah, a global overview of the system resources. So the amount of disk space that's used, the number of jobs in the system. Now, how does a job know in what subsystem pool it has to run? Well, a job has this job description that was also on one of the previous slides. It was a default job description there. And this job description has some job attributes, which are not runtime attributes, but some other stuff. And so especially, it contains routing data. And when the job is taken off the job queue by the subsystem, it compares this routing data with a few routing entries, and the routing entry defines which subsystem pool the job should run in, and also it assigns or chooses under which class the job should run. And there, in the class object, are the runtime attributes of the job. Yeah, I have a print screen of that later. So this is a default routing entry, that, or some routing entries, and the one with the red box is the default one. And this is, if this routing entry will make sure that the jobs that match it will run in pool ID 2 and will use the class queueInter. And this is our details of the class. So you can see that there will be, the job will run under a priority of 20, and there, for example, will be no maximum CPU time. Will be no maximum CPU time defined. Okay, so that's the basics of how a job is processed on the system and where it gets and how it is started. So some other stuff. So everything on the system is actually an object, and there is a special type of object called a library, which contains objects except all objects except other libraries. So you only have on the file system one level of hierarchy. Yeah, the IBM supplied libraries start with Q or a cross. And objects, they have a name of maximum 10 characters and are uniquely defined by name and type. And it's an ABCDIC system, so if you take data from it, you have to convert it to ASCII. This is an example of 3 files that live in the same library, but have 3 times a different type, so they can coexist in this library. The system has multiple file systems available, provided by the integrated file system. And the default file system is QSys, the native AS400 file system. But you also have a POSIX file system called QOpenSys and QOptical for CDs and DVDs. And also things like NFS and SMB are supported by the integrated file system. This is an example of a file that lives on the QOpenSys file system with some Unix permissions. And yeah, you have users on the system, which is not so strange. And the main user, which you can compare to the root user on a Unix system, is called QSecOffer, the security officer. And all users have assigned some authority levels in their user profile. And there are also group profiles where you can add the authority levels, and you can put users into groups. So this is an example of my home library on the QSys file system. And I have all permissions and everyone else is excluded. But for example, the QSecOffer user can do everything with it because it has the all object authority permissions assigned. So the user profile is also an object. And yeah, you can specify a program. If you log into the system, you can specify a program that should be run, or a main menu that you want to see. And you can also enable, disable users and expire their passwords. So navigating through the system is done by commands or menus. And that's actually, I like that a lot, Because if you are looking for a command that starts, for example, with DSPP, the commands are all built up by some abbreviations. So, for example, display or work or change, and then every time it's 3 letters. But if I don't know the program exactly, and I know it starts with DSP, I can type DSP star, and I get a list of all the programs that start with DSPP. And then I can just select the program I want, and it will run for me. And I can put the values into these boxes, which I also like. And one nice thing is, for example, in the details box there, you have a few values that you can put in, but there are 3 points. And if I don't know what other values are possible there, I can just go to that field and press F4, and it will give me a list of everything that I can put in there. Now, if I don't know what all these options mean, I can just go to the options and press F1, and I get the manual of the options. So I like that. I wish that I had that on Linux. Another way of navigating through the system is with menus, which are also objects. This is an example of the main menu, and this is an example of another cool menu. It's called the major menu. And you can go and look for a command by search for it by topic. So you see there, yeah, it's all in Dutch, but if you want to find something about files or printing, security, programming, you can go to search a program in that topic. So for example, if I wanted to do configure my TCP/IP device, TCP/IP on the system, I can go to configuration, then choose TCP/IP, and I will get in the configure TCP/IP menu. And then I can choose to configure my interfaces, and I get a list of all the interfaces that are available on the system. Okay, so one last thing I wanted to say is, so you can also redirect the output of a command to an out file, which is then a DB2 file. And because it's a DB2 file, you can select data from it with SQL. And this SQL is also promptable, so you can select fields and just choose them for your query. And you can also create new files with SQL, put some data in it. And as you can see, these are all objects of type file on the file system. So that's basically the most important things I wanted to say. I also wrote a little paper, which I will also upload, which has more technical details in it for every topic that I discussed. So I thank you for listening. If you have questions or want access to the system, just ask.
Is there anybody who would like to ask a question, and I can bring the microphone to you?
Are users also objects?
Can you repeat the question?
Are users also objects?
Yeah, users are also objects, and they have a message queue assigned. So you can also, if you run a program, the message is posted to the message queue of the user's object. so users are also objects. And the user profile is also defined in another type of object. Yeah, the user profile object. Yeah.
What does a crash look like?
A crash?
Stack Overflow, the equivalent of the blue screen of death, kernel panic, and any kind of core file or what appears on the screen, what is...
I never actually saw a big crash, so I don't know. A program can crash, but I never saw the entire system crashing, so I really don't know.
Thanks. Is there an online user community for these kind of systems?
Can you repeat the question?
Is there an online community, user community for these kinds of systems? An unofficial IBM community?
Yeah, there are some user groups. I think, yeah, I can look that up. There are actually user groups for the system. For example, the mid-range system user group, and there's also yeah, I can't get the name. Yeah, there are user groups. If you drop me a mail, I will reply to you and give you the names of the groups.
Can you tell me what kind of environments you typically find in AS400 and how does it scale to a size of a company?
One more time.
Can you tell me what kind of environments you'll typically find in AS400 and how does it scale with a company?
Yeah, for example, the logistics sector still uses the AS400 systems a lot. For example, in the harbor, and yeah, they use it. But I'm not really a guy that calculates and scales systems or does these calculations for customers, so I don't really know.
Maybe I can have an answer to that. I think the AS400 is mainly used in administrative systems, but you can find them everywhere in banks, healthcare, transport, etc. Now, if you take one of the very smallest system, you might have in newer workloads, say Java or Portal or anything, only a few scores of users on them. But if you go to the larger systems, like for instance the ABN AMRO bank in the Netherlands has some 595s, so that are systems with 64 processors, so actually 128 processor cores on them. So they can run tens of thousands of users concurrently using both traditional screens, like the green screens we saw, as Java programs through Portal, etc. So that's no problem at all. So scalability is one of the strengths of the system, I think.
It just looks like a fanboy.
He does have an I want an I t-shirt, so...
I have a question for the differences between the different versions of the operating system. If I would go out now and buy an old machine like you have now, just for playing around, are there big differences to the new iOS, or is it quite similar?
It's quite similar, but there were many features added. For example, the pace environment is not available on my system. And also, yeah, things like LPARS and stuff is only available on the newer systems. So you would, yeah, you have to buy a management console to do the LPARS, and I think, but I'm not sure, you have to have a Power 5 at least for this.
From what time did TCP/IP appear on the system?
Excuse me?
What time did TCP/IP appear on the system? I only played with on Twinx, but
I don't know. I don't know.
Your screenshots look very similar to the ZOS environment stuff. How compatible are the programs to ZOS?
No.
Or how easy it is to port programs from AS400 to the ZOS environment?
I do know that IBM in the past tried to make the System 38 and AS400 programs run on the System Z, or the System 390, I think, at that time. But they failed, so it's really not compatible.
You have TCP/IP on the machine since '96, and you can run it perfectly together with the Twinx network. And my question is about security. It's like I never read about a hack on the system. Like there are no publicly available exploits like for other systems. And the question is, if you ever heard about something in the really in the core system, like the hardware management console is basically a Linux appliance where you plug in with a 2.4 kernel. I think that's pretty crap. But the machine itself is unbroken. Like you can't change between LPARs or something.